Hey guys, what's going on? In this video, I'm going to show you how to build a RAG application in Next.js using LangChain. So you can build your own custom chatbot, which can answer users' questions based on your custom data sources, which can be any type of data. But for this video, we're going to be focusing on PDF documents. So if you're interested in learning more about RAG, I'll leave a few links in the description. You can check them out if you're interested. So without any further ado, let's get started. All right, so moving on to the coding part. Here, I'm going to make an API route. I'm going to call it load documents. The purpose of this API route is going to be to load the documents from your data source and then store them inside of a vector database. Now, if you're wondering about where all these files came from, this is just a project I was working on before. You don't really need to worry about them. Let's just focus on this API route for now. Okay, so we're talking about loading the documents. There's actually many ways this can happen. So the first and the most simplest way that we're going to discuss is loading a single PDF document that can be stored locally. So how do we do this? So LangChain has a function called PDF loader. I'll leave a link to this in the description. You can just head over and read the description. You also need to install a couple of these packages. You can go ahead and install them. I already have them installed. And then you need to import PDF loader. You can just copy and then paste that in here. I've already done that. And then what we need to do is you can just do const loader is equals to new PDF loader, and you just pass to this the path of the PDF file that you have stored locally. So as simple as that. And then what if you have multiple PDF documents that are all stored locally? The way to do that is LangChain has another function. It's called multi-PDF loader, I believe, multi-file loader. So you can just copy this, right, and then paste that here, the import statement. Okay, and then how do you actually use this? So this is how you use it. Let me just copy this and then paste that over here. Okay, so you can actually have two of those. Let me just remove that. So const loader, then you do new multi-file loader, and you specify the paths to all of the PDF files that you have stored locally. Well, they don't actually have to be PDF files. It can be any type of file. So TXT, CSV, JSON, or JSON-L. And then the second argument that you pass this as a second parameter is going to be the handlers for this basically. So let's say, what if you have a JSON file? It's going to take that path and it's going to call a JSON loader. So you call the loader based on the type of the files that you have. So if you have a text file, you call the text loader. But what if there were, in our case, they're all going to be all PDFs. So let's say we have multiple PDF files that are stored locally. How are we going to handle that? You can just have one handler for PDF, and you can call a PDF loader. PDF loader. Yeah, you can call a PDF loader, and this is gonna work. Okay, but what if you have a single PDF document that's stored externally? So you're not actually storing them inside of your project. You're actually storing them, let's say, in a database. You're storing it as binary data or something. How would you go about loading those documents? So the way to do that is actually there's there's a function called web PDF loader. You can go ahead and I need to install these if you haven't already, and then you can just go ahead and import. I think I already have imported. Yeah, you can import the web PDF loader, and then what you need to do is you can simply do the same thing as we did before. So I'm going to call it loader. So you spelled that wrong. Loader is equals to new web PDF loader, and you can pass to this a blob as well, as we can see here. You can pass to this a blob. So you can do a read from a database, you can read the file data from your database, which is going to be a blob. So const, you do something like const blob is equals to, this is where you do a read from your database and you get back a blob, and you can simply take that blob and then pass that as a parameter to this function, and it's going to work just fine. But what if you have multiple PDF documents that are stored in a database? This could also happen. This could also be a case. So LangChain doesn't actually have a built-in function to deal with that. So the way you need to do it, and the way I've done it, before, the way I did it in my code is I do a read from the database where I get all of the files. Then I download those files. One by one, and I push them to an array called blobs. So I'm basically getting all of the files that are stored in my database as blobs. And what I can do is I can run a loop through them, go through them, iterate over each of these blobs one by one, and I can call the PDF loader function on those docs, on those blobs actually, and this is going to give me back a loader object. So what do we do after we get the loader? You actually need to call the load function on the loader, which is actually going to give you back the content that is stored inside of this blob as a document. So document is actually an array of documents where each element stores the content, the page content from each one of those pages. So let's say you have 10 pages. This is going to have 10 elements where each element represents the content from that specific page as a document object. And that's actually an array of documents. So what you can do is you can have one single array, and I call the docs over here, and you can just concatenate this doc to this array every single iteration. So by the end of this loop, you're going to have an array of documents which stores the page content, stores the content of that document for every single page in your all of your data sources. So this is going to work. This is going to give you all the data from your PDF documents. So that's how I did it. That's how you can do it too. So after you've done that, after you've successfully gotten your all of the content from your data sources as a document and as an array of documents, what you can do is you need to use a splitter, a text splitter. So this is how you set it up. LangChain has a text splitter. What is this? Recursive text splitter. You can just copy this and then just import that up here. I've already done that. After that, you need to create a new splitter, and you need to specify what's going to be the size of the chunks. So you're going to take your documents, you're going to split them into separate chunks, right? You need to specify how many characters is that going to be. I specified it as 1,000 characters. You can increase that or decrease that as you like. You can also set a chunk overlap. It means how many characters are going to overlap between these chunks. So let's say you have a chunk of 1,000 characters and 1,000 characters. There's going to be 200 characters that are overlapping. So that means there's going to be 800 unique characters in each chunk. Okay, so you take the text splitter and you call the function split documents, which will basically take this text splitter and apply it on the documents. It's gonna you're gonna need to pass the docs, which is the array of docs that we got here, and this is gonna give you back. This is also going to give you back, as you can see, an array of documents. Now it's actually not. It's not storing each element doesn't store the page. Each element is actually chunks. So it's basically an array of chunks where each chunk represents some part of the data from your data source, which is going to be actually 1,000 characters as we specified with 200 overlapping characters. So there's going to be 800 unique characters in each chunk. Okay, so after we've done that, we've gotten our chunks of data. What we need to do is actually This is something I came across. If you don't do this, it's going to throw you an error later on. So it turns out if you have \n characters inside of your page content, it does actually show you an error when you try to uh, further in the flow. When you try to use it with the chatbot and it tries to pass this data, it throws an error if you have \n characters for some reason. So I've written some code here to deal with that. I'm running a loop through each one of those splits, which is actually a chunk of text, and I'm replacing the \n with an empty string. So that's just simple regular expression. Okay, after that, we need to specify the embeddings model. So in this case, I'm using Google Generative AI embeddings because I'm going to be using the Gemini 1.5 Flash model for this. If you want, you can use OpenAI embeddings if you're using ChatGPT or something like that. There's many different options for embeddings. You can look that up here. You can search that in the documentation. You can search for embeddings, embedding models. You can search that up in the documentation to find out which model you want to use. After you've done that, you also need to specify an API key, which I've already set up in my environment variable file. You need to specify a model. They do have default models. I'm not sure. You need to check with the with the embedding model that you're using. Do they have a default model? And what's the dimension? The thing you need to note down is what dimensions do these models does this embedding model use? Because we need to specify that later on. Okay, so after you've done that, you have an embedding model. You need to create a vector store. So vector store is basically responsible for managing the vector store, as the name suggests. It's going to handle storing the data into the vector database, and it's going to manage retrieving the data from the vector database. Okay, so in this case, I'm using the Zeta vector search. So what is this? Okay, so LangChain actually provides a bunch of options for, I think I had it open. Yeah, so LangChain actually offers many different options for different database providers that you can use for your vector store. So this is where your vector data is actually going to be stored. There's many different options which you can use. There's MongoDB, Postgre, pgvector, Pinecone, which is also pretty popular. In my case, I'm using Zeta. So once you've decided which one you want to go, which one you want to pick, you can just click on this, click on its name, and it's going to take you to a page where you can see all the information about it. It's going to show you how to set it up. In my case, it's asking me to install this Zeta CLI, which I've already done. You need to follow all of these steps. They're going to ask you to create a new table. You need to have a database. You need to have a table. You can name it anything you want, but keep in mind what the name is because you need to refer to it later. And it's going to ask you to create specific fields of specific types. So it's asking us to create a field called content of type text. It's telling us it's going to use it to store the page content, which is actually the content of the document. And you need a field named embedding, which has to be of type vector, and you need to specify the dimensions. So 1536 is for OpenAI. In my case, I'm using the Google's Generative AI embeddings model embedding 001, which uses 768 dimensions. So that's what I specified when I made this field. I already have the database made. And another thing, you can store metadata. So what is metadata? So by default, when we load our documents and we perform a split on it, we can actually do a console.log here on the splits. And you're gonna see that it has two fields stored in metadata. One of them is called PDF, and its type is going to be of JSON. Another field called log is called it's also of type JSON. So they're asking us to create fields for whatever metadata you have. You also have to specify what the type of that data is. So you'd have to create these two extra fields inside of this database and specify the type of JSON. Okay, so after you've done that, you need to actually call the add documents function, which is going to do as the name suggests. It's going to add your documents to this vector store. And that's basically it for this API route. All right, so moving on to the next part, I'm going to create a new API route. I'm going to call it chatbot. The purpose of this API route is to basically generate a response from an LLM and then send that back to the user. Okay, so don't worry about all these import statements. We're going to walk through them one by one. So outside of this post function, I've defined a bunch of constants and a bunch of helper functions. Let's walk through them one by one. I have an API key, which I've stored as Gemini API key because I'm using Gemini. I have a function called combine documents function, which basically takes a bunch of documents as input, an array of documents as input, and basically gives us back a new array which stores only the page content of each of those documents. So remember I said that we have chunks of text which are stored as documents. Each of the document is going to have a page content. So it's basically going to store all of the page content of the chunks of data that we have, and it's going to return back to us a single string which is going to separate each of those page contents by a blank line. So it's going to look something like this. You're going to have, let me show you an example. So text 1, then text 2, text 3. They're all going to be separated by a new line or blank line. Okay, then I have something called a format message function, which basically takes a message, formats it in this specific way. So we have the role of the message, which can be either human or AI, and then we have the message content. This is just formatting the message. Okay, then we have a prompt template. This is a very simple prompt template. This just says you're an assistant for question answering tasks. Use only the pieces of retrieved context and chat history to answer the question. If you don't know the answer, just kindly reply that you don't know. Okay. We need to also add these placeholders for context, chat history, and question because we are going to be plugging in values into this prompt template. Okay, so moving on to the post function, I have logic here to check if the user is authorized or not. If the user is not authorized, we just return back saying you are not authorized. Then we're actually going to be passing in the messages to this function as input in the request body. Messages is going to contain all of the previous messages. That's your chat history and the current message, which is going to be the user's question. I have a Zeta client here because I'm using Zeta. You could be using any other database that you want. And as I just explained to you, we're going to have messages is going to store all of the history. So basically we're getting everything from the first element to the second last element. That is your chat history. And we're going to apply the format message function to that. So it's going to store the role of the message and what's the content of that message. That's the formatted previous messages. We have the current message content, which stores the current, the most latest item, the last item in this array, which is the content of the last message stored in this array, which is basically going to be the most recent message, which is going to be the user's input or the question. Then we're creating a prompt. So you cannot actually use the string template directly. You actually have to create a prompt. So this is you have to import prompt template from LangChain. So you can do it like this from LangChain core. If you've installed it, you need to first install it. I think I showed in my previous in the previous steps. You have to install a bunch of packages from LangChain. You can just search up prompt template here, and you can see how you're supposed to import. Where is it? Yeah, you can import it like this. Just copy and paste that here. Okay, so that's the prompt template. Then you need to create a new model, which is going to be your large language model. So in my case, I'm using the Gemini model. So I'm using Chat Google Generative AI. If you want to use this as well, You can search that up, or whatever AI model that you want to use, maybe ChatGPT. You have to install the corresponding packages for that. In my case, it's going to be I have to install all of this. I have to install this package called Google Gen AI. But if you want to install, if you're using ChatGPT, you probably have other packages which you will have to install. So once you've done that, you've defined a model. You need to define the name of the model actually. So I'm using Gemini 1.5 Flash, and then you have to also specify an API key, which I've defined above. Then you need to, just like before, create embeddings. I'm using generative AI embeddings. You need to pass in the API key, the model name. You need to create a vector store. You need to pass in the embeddings, the client, which is a Zeta client because I'm using a Zeta database. You need to pass in the name of the database, the name of the table actually, which is vectors. That's where all the vectors are stored. And then you need to create a retriever. Now what a retriever does is basically it retrieves documents from the vector database. Then we're going to create a retrieval chain. What a chain basically does is we're going to take the retriever is going to retrieve the documents for us. Then we're going to pipe that to the combined documents function. So it's basically going to pass the output of the retriever, which is going to be basically a bunch of documents that you retrieve. You pass them to the combined documents function, which, as we discussed before, it takes the documents, gets the page content for us as separate elements in an array, and it basically returns back to us a single string which has all of the page content separated by a blank line. It's going to do that for us. That's what the retrieval chain will do. All right, so you also need an HTTP response output parser. What this does is basically, you also have to import it up here like this. Import HTTP response output parser from LangChain output parsers. You can even search that up in the LangChain.js documentation to read about it in more detail if you want to. Well, basically what this does is that it takes the output and it parses the output which we get from the large language model. It handles the serialization and encoding so it can be sent over as chunks of text. Okay, then we also need a chain. What this chain does is basically we have a runnable sequence. You also have to import this runnable sequence from LangChain core runnables. You can even search that in the documentation, but what this does is that it takes an array where each element is a runnable. Now, runnable in LangChain is basically a function or a component. So let's walk through them one by one. The first element has three properties: question, chat history, and context. So when we call our final chain, we're going to pass two inputs to it, which is here. We're going to pass to it a chat history, a question. So chat history is basically all of the previous messages, and the question is what you currently have, or what's the most recent message, basically. We're going to pass that here, the input question and input.chat history. And then we also need something called context. So we have another runnable sequence from. What this does is it takes the input question, right? It takes the input question, and then it calls, basically passes that as input to the retrieval chain, right? So as we discussed before, what does the retrieval chain do? It's going to take, based on the user's input question, it's going to use the retriever, which is the vector store retriever, to retrieve certain documents. It's going to pass them to the combined documents function, where it's going to, as we discussed before, it's going to give us back the page content of each of those chunks of text, return back to us a single string where each page content is separated by a blank line. That's what this is going to do. This is going to give us back three pieces of data: question, chat history, and context. So all of that can be passed as input to the prompt. Now, if you remember what the prompt was, it basically has three placeholders: context, chat history, and question. So we're going to plug those values in here, like what the context is, which is basically the pieces of chunks of text retrieved from the vector store, and then your chat history, which is all of your previous messages and the question of the user. that's going to be plugged into the prompt template over here, and that's going to be passed as input to your model. Now what your model will do is going to take this input as text, and it's going to give us back a response. And that response has to be parsed by the HTTP response output parser that we defined above. Where is it? Yeah, right here. It's going to parse the output. And then what we need to do, that's basically our chain, right? We can call the chain.stream basically means it's going to return back to us output as a stream because we're going to stream the data back to the user. We need to pass the chat history and the question as I explained before, and that's basically going to give us back a stream object, iterable readable stream of type Unit8 arrays. Okay, so that's our stream. And something else that we need to do, we need to use functions from the Vercel's AI SDK. So Vercel has its own AI SDK. I'll leave a link to this in the description. You need to go ahead and install this. Copy, I've already installed that. I've already installed this package, so I don't have to do it again. Well, basically what you need to do is you need to import all of these because we're going to be using them. You need to import the message streaming text response and create data stream transformer. So what we need to do is after we have the stream response back from the LLM, from a large language model, you need to convert that to a transform stream and then wrap it into a streaming text response, which basically, as the name suggests, it basically allows you to stream back text to the user over HTTP, basically. So an HTTP response, which is basically going to be the text data you got back from the LLM. So yeah, that's it for this API route. All right, so moving on to the UI part, we have a folder called chatbot, which I made inside the app folder. So first of all, what we need to do is we need to use the useRef hook. I'm going to create a variable called chat parent. I'm going to set it to null initially. So this is going to actually help us to handle the automatic scrolling functionality. So as new messages keep coming in, we want our UI to keep scrolling down, basically. That's what this is for. I'm going to talk about this a bit more in a while. Let's focus on this for now. So we're going to use something called the use chat hook, which comes from the Vercel's AI SDK. I'm going to leave a link to this in the description. You can head over to this, and if you want to read more about it, you can do that. You need to import this, which you can paste in here. I already have that here. And what you need to pass to this is the API route, which we made before for the chatbot, which is this API route. Actually, it's API/AI/chatbot. Yeah, this is the API route that we made before. It's going to generate responses and send it back as a streaming text response. And there's also a bunch of other callback functions which you can use. For example, there's onError. So if there happens to be an error, you can handle that over here. There's also many more functions that you can use, but for this video, this is all we're going to use. You can also use something called onFinish. So this is something pretty useful if you want to save this chat history somewhere in an external database. You can do that using the onFinish. So basically, when the response is finished generating, what's going to happen? You can define a function for that, and this is going to return back to us 4 things. Messages, which is basically an array of messages, which includes the chat history and the current question, and the response as well. The current response has the input, which is the user's question, and has 2 handle functions, which is basically to handle input change and handle a submit, because we need a form here we're actually submitting a form here. We need to pass the handle submit function to the onSubmit. So yeah, these are the 4 things which use chat returns. There's also something called isLoading. We can use that as well. So basically, while it's loading, you can do something like maybe show a spinner or something, but I'm not going to do that. Okay, what else? So we have a use effect here. which is basically going to take care of the automatic scrolling. So it's going to get the DOM node, which is chat.current, chat.current. So I have a UL here. I'm actually going to leave a link to this code in the description so you can just refer to this. But this is a UL, element, and I passed the chat parent as a reference. So we can refer to this element basically. And it's going to set the scroll top to the scroll height. Basically what this is going to do is going to make sure that the UL is always scrolled to the bottom. It's gonna always be scrolled to the bottom. So as new messages keep coming in, it's gonna be always scrolled to the bottom, which is exactly what we want. And yeah, you just have what you can do is just map over the messages one by one. You check if the length is more than 0. You can map over them. You have the element, you have the index. You can just another thing you need to do is, based on whether it's the user message or it's a message from the AI, you can have different styling for that. So what I did was, if the index is an even number, which basically means that it's a message from the user, right? Because the first message, the messages which have an index of an even number will always belong to the user, basically. You can also have a different type of check. You can check if another way to do this would be if the message, you can check for the message.role equals to human. That would also work, but I prefer doing it like this. You can it's simpler to just check for the. I prefer to just check for the index. If it's an even number, you I'm just gonna make the background a BGF slate of 700. Otherwise, it's gonna be 600. It's gonna be a bit lighter, basically. So you can have different styling for whether based on the role of the message. And I've also added a small span at the top. So if it's an even number, means it belongs to the user. I can just add a span of user, otherwise a span of AI. And then you can just access the element content. So each message has two properties. It's going to have a role and it's going to have content. So you can just display the content of that message. And then you also need a form, as I said before. To the form, you need to pass the handle submit, which is returned by the use chat hook. Returns the handle submit, which you need to pass in for the on submit for this form. And it's going to have an input and a button. Input is basically where you're going to type in, where the user is going to type in their question. And you need to pass in the handle input change, which is returned by the use chat over here. You need to pass this to the on change to the on change, and the value for this is going to be the input, which is also here returned by the use chat. Yeah, so these are the things which you need to pass in, and then you need the button. You need a button, and how the button has to be of type submit. That's basically it. I'm going to leave a link to this code so you can use this for reference. So yeah, that's it for the chatbot. All right, so just to give you guys a quick demo, I've run npm run dev, and I've started a server on localhost. And before we can actually try to use the chatbot, you need to run the load documents function. And the purpose of this API route, as I told you before, is to load the documents into a vector database. So you can run this API route however you want. You can use any one of these methods which I told you about to load the documents to vector database. And after you've done this step, after you've loaded the documents, now you can use the /chatbot page. And this, as I told you before, uses the API route AI/chatbot. And the purpose of this is to basically generate a response and give it back to you, give it back to the user, which is in the chatbot page. So we can see what that looks like. If you head over to /chatbot, you should get a page which looks something like this, except for the nav bar that I've added at the top. You should get a page which looks like this. If you try to ask it any question, it should be able to answer. And if you ask it any question based on the custom data that you provided it with, that is your custom PDF documents that you've stored in the vector store, you can ask it questions based on that. So in my case, I provided it with data about Next.js. So I can ask it questions about what is Next.js, and it should be able to answer those type of questions. However, if you try to ask it anything that's outside of its knowledge base, that is the custom PDF documents that you provided it with, because of the prompt that we used, where is it? Because of the prompt that we used, we asked it to use only the pieces of retrieved context and chat history to answer the user's question. So if we try to ask it anything outside of its knowledge base, it should not be able to answer. For example, who is the president of UK? It should not be able to answer those type of questions. And even another thing, this does also have access to chat history. So if I ask it like, what is the last question that I asked you, it should also be able to answer that type of stuff because it has access to the chat history. Yeah, okay. So yeah, that's it for this video. If you have any questions, feel free to ask in the comments below. And if you'd like to see more longer and more detailed videos about this project, do let me know in the comments below. And thanks for watching.